So, organic chemistry for medical students, and more likely this is going to be your first topic, stereochemistry. Stereochemistry. Now, in stereochemistry, what you want to talk about, we are going to be talking. This is a lot, trust me. You are supposed to have done this topic in first year. I don't know if you did, but I don't think you did. So, start first with nomenclature, how to name compounds, okay, and also isomerism and calculations. This is a very interesting topic. I love it. Now, the first thing is we need to know the rules of naming compounds. You might have done it in first year or you might not have done it. The first thing, when you want to name an organic compound, the first thing that you must do is you must be able to locate the longest continuous chain of carbon atoms. So you can start counting from any direction as long as you find the longest chain, all right? The longest chain of carbon atoms. Now, it shouldn't just be a longest chain, it should be continuous. That is one of the most important things. So, for example, this one you can see 1, 2, 3, 4, 5, 6. I could have also gone down, it could have still given me a 6. Now, when you do that, always make sure that if there is any group, give me a moment. Okay, sorry for that. So, we are saying that when you are counting the longest continuous carbon chain, what should you do? You need to make sure that the if there is any group coming out, it should receive a smaller number. That is important, all right? So, for example, you can see we have got this group. So, when I'm counting, it's not right for me to start counting from this direction. Instead, I need to count starting from this direction, going in this direction. Now, sometimes the longest continuous carbon chain might not be that obvious. As you can see for this one, we add to bend, and then this gives us the longest. Because if we went straight, we would have just found 6 carbons. Okay, this is very important, very important. And then after you count the longest continuous chain, number the longest chain with the end of the chain nearest to any substituent. So you can see this is a substituent, so we are numbering from this direction so that it receives a smaller number. This is the substituent, we are numbering from this direction so that it receives a smaller number, not the other way around. And then use the numbers obtained by the application of the second rule to designate the location of any substituent. For example, this one is a substituent and it's at position number 2, right? And then this is a substituent is at position number 3. Now, when you are naming substituents first, look at how many carbons there are. You need to know that what are the prefixes. A compound that has got, I'll write the carbons here and then the prefixes. Now, you people don't like answering, so I'll not be asking you, I'll just be talking. So, carbon 1, if a compound has got only one carbon, that is a meth. 2 carbons, that is eth. 3 carbons, that is prop. 4 carbons, that is a but. 5 is a pent. 6 is hex. 7 is hept. 8 is oct, 9 is non, and 10 carbons is dec. So this is what you need to know. So for here, you can see we have got a group at position number 2, but it has got only one carbon. If you just see a line, at every end of a line, there is a carbon. So meaning that you only have one carbon here. And what is the prefix? It's a meth. So always start with the position where the group is. This is 2. What is the name of the group? It's a meth. Now, if it is a group, it is known as an alkyl group. So we put "-u" at the end. So that is methyl. The longest chain has got 6 carbons. 6 carbons, the prefix is hex. But because it has no double bond, it's all single bonds throughout, that's an alkane. So hexane. This other one is 3-methyl heptane. You can see between the name of the substituent and the main chain, there is no space there. And then between the number and a letter, there is a dash. So you always separate a number and a letter with a dash. And then next rule, when you have got 2 or more substituents present, give each substituent a number corresponding to the location on the longest chain. For example, this one, if you start counting, where are we going to start counting? Start from here: 1, 2, 3, 4, 5, 6. Why didn't I start from this side? Because if I started from this side, the first group would have received the 3 as a position. I need to start from the direction such that the first group will always receive a smaller number, right? So in this case, but when you are naming the groups, this group has got only one carbon, is a meth. This other group has got 2 carbons, it is the eighth. When you are naming, you name according to alphabet. So you first name E before M. So the E is at position number 4. So that is 4-ethyl and then 2-methyl hexane. You are separating a number and a letter, you are using a dash. If you have got the same compound, you can use things like die and such. How about if the groups are on the same position? So for this one, first count the longest chain. 1, 2, 3, 4, 5, and 6. You can see at position number 3, you have got 2 groups. One is a meth, the other one is an eth. Same, when you are naming, always make sure that you include the positions at which they are. So 3-ethyl and then 3-methyl hexane. So you write the 3 twice. If the same group is repeating, you can use things like di, tri, tetra. For example, it says 1, 2, 3, 4. You can see at position number 2, you have got a methyl. Position number 3, you have got a methyl. So you say 2, 3 dimethyl. When you're separating two numbers, you use a comma, a number and a letter, a dash. So 2, 3 dimethyl butane. For this one, 1, 2, 3, 4, 5. Position number 2, we have got a methyl. Position number 3, we have got a methyl. Position number 4, a methyl. So this is 2, 3, 4. There are 3 trimethyl. For this other one, 1, 2, 3, 4, 5. Position number 2, I've got 2 methyls. So we'll mention it twice: 2, 2. Position number 4, I've got 2 methyls: 4, 4. And then, because there are 4 methyls, tetramethyl. The O chain has got 5 carbons, pentane. Okay. When two chains of equal length compete for selection as the longest chain, choose the chain with a greater number of substituents. Look for example, this one. You can see going forward how many. The longest chain has got 7 carbons. But if I went down 1, 2, 3, 4, and then I went down here 5, 6, 7. It also has 7 carbons. But if I went like this, the only groups I would have had is 1 group, 2 groups, and then this would be 1 group. So only 3 groups. But when we went straight, how many groups did we find? This was a group 1, this is a group 2, this is a group 3, and then this is a group 4 groups. So go in the direction that will give you a lot of substituents. So when you are naming, name in alphabetical order. So this is a methyl, This is a methyl. This is also a methyl. And then this one has got 3 carbons, so it's a propyl. So M comes first than P. So it will be 2, 3, 5 trimethyl and then 4 propyl heptane. That becomes the name. When branching first occurs at an equal distance from either ends, choose the name that gives the lower number at the first point. If you start counting from this direction, you can see the first branching is a 2. If I started from this direction, 1, 2, 3, 4, 5, 6. The first branching is still a 2. Now you need to look at the next group. So for the next group, if I started counting from this direction, you can see the next group is at position number 4. If I started counting from this direction, the next group is at position number 3. So count from the direction that will give the next group a smaller number. So that becomes 2, 3, 5 trimethyl hexane. Okay, so we can practice on this. Anyone to tell me where am I going to start counting from? Let me label A, B, C, and D. Where are we going to start counting from? From A, B, C, or D? From D. Okay, very good. So this will be number 1, number 2, number 3, number 4, number 5, number 6, number 7. So what is going to be the name? Look at the numbering. What is going to be the name of this compound? Okay. 2, 4 dimethylheptane. Good. Okay, so that is the name. Now, how do you name alkenes? So the naming of alkenes is also the same as the naming of alkanes, except doesn't end in N, it ends in in. Okay. So always for you to name an alkene, the only thing is that count in the direction that will give a small number to the double bond. So for this one, you can see where we're starting. We're starting counting from here. We could have started from here: 1 carbon, 2 carbons, 3 carbons, 4 carbons. We don't start from that end. Why? Because the double bond is going to receive a big number. So when you are naming, always state the position of the double bond. Now, a double bond will always be between 2 carbons. So here it is between carbon number 1 and carbon number 2. Always select the smaller number. So select 1 as the position of the double bond, not 2. So you say 1 butene. Or you can say but, and then you write a dash, and then you put 1, and then you write now N at the end. This is actually the most common that you'll be able to see instead of 1 butene. For this other one, this will be 1, 2, 3, 4 carbons, 5, 6. So this one will become 2-hexene or hex2-ene. Okay, so that is how you name that. How about this? So look at this one. If you want to name it, you are starting counting from. For this one, you can start. Look at the way it has been given. It's been given like this. If I start counting from here, 1, 2, you can see the top bond is at position number 2. If I start counting from here, 1, 2, it's still at position number 2. But I'll not start from counting from top. Why? Because I've got a group. This is going to be a group. So even when I'm looking at the double bond, I also need to look at the group. We should also receive a small number. That is why we start counting from this direction. So when naming, you always first name the group. So that is 2. The group is at position number 2. So that is 2 methyl. And then this one has got 4 carbons. So it's a but. The double bond is at position number 2. So but2n. For this other one here, you can see it has got 6 carbons. But you have got 2 methyls at position number 2 and at position number 5. So say 2,5 dimethyl. 6 carbons is hex, and then you put the position of the double bond, that is position number 2, and then you put N at the end. If you look at this one here, if you miss this, trust me, chemistry is one tricky course. This is a course, it's not a topic. So I can also write this one. It has got 4 carbons. I can write it like this: 1, 2, 3, 4. There's a double bond here. And then there's a chlorine at the end. This one they've given, I can also write it like that. Or where should we start counting from? I can either start from here: 1, 2, 3, 4. Or I can start, you don't number the chlorine, it's not a carbon. Or I can start from here: 1, 2, 3, 4. Start from the direction, because you can see the double bond is receiving the same position. So start from the direction that will give a small number to the chlorine also, because the double bond is receiving the same position. So start from this direction. So the name becomes 1-chloro but 2N. Now for this one, if you start counting from this direction, the groups will receive position number 2. But priority does not go to the group, priority goes to the double bond. So that's why we start counting from this direction. You can see I've got two groups, two methyls at position number 5. So that is 5,5 dimethyl. And then this one has got 6 carbons, hex, and then 2N. You can also have cyclic compounds. Now for cyclic compounds, what you want to do is, let's say we had something like this. Always start to count where there's a double bond. But when you start counting from where there's a double bond, always make sure that you cover the double bond in your counting. Always cover it. So if I start from here, I can't go in this direction. Okay, I can't go in this direction. Okay, so I'm saying I can't go in this direction. Instead, I should go in this direction. Why? I need to cater for the double bond. So be 2, so be 3, so be 4, so be 5, this will be 6. So 6 carbons, we know that is hexene. But because it's cyclic, just put cyclo in front, cyclohexene. Now, for something that is cyclic like this, if it doesn't have any substituents, it's not necessary to put the position of the double bond to say it is cyclohex1N. It's not necessary unless it has got groups. Okay. You can see also for this one, you are starting to name where the double bond is. I could have started naming from here, but I'll opt to start from here because there's also another group that needs to receive priority. So that is why we start counting from there. So the name becomes 1-methylcyclopentene. You can see you have not even put the position of the pentene to say 1-methylcyclopent1, and we have not even put that. Okay. Sometimes you can have, how about if it's an alcohol, but it has got a double bond? Now priority changes, priority is going to go to the double bond instead of it going to the, priority changes to the alcohol instead of to the double bond. So always number such that the alcohol receives a small number. So you start from this end: 1, 2, 3, 4. So when you are naming, because it's 5 carbons, there's a methyl, you first name the methyl, 4-methyl, and then this one. So we are saying 4-methyl. This is 5 carbons, so it is pent. We are supposed to have said pent. Go to the position of the double bond is at position number 3, pent 3. We are supposed to say pent 3N, but this is not an alkene, it is an alcohol. So drop the E at the end and then put the position of the alcohol at position number 2 and then put O at the end. So that becomes the name 4-methyl pent 3N2O. Okay, like that. Now you can also have some special groups which we call vinyls and allyls. When you have got a carbon bonded to a carbon and then another carbon, this carbon atom that you can see here that is in a double bond, we call it a vinyl carbon. Even this carbon is in a double bond, all right? That we are going to refer to them as vinyl because they're in a double bond. And then a carbon bonded to a carbon in a double bond is an allyl. It is not having a double bond, but it's bonded to a carbon in a double bond. So that is how we classify carbon atoms. So let me talk about how you classify them. Let's say we have got a compound like this. Classify all the atoms in this molecule. So if you look at this carbon at the end here, it is in a double bond. So it is an allyl carbon. Even the hydrogens attached to it are allyl hydrogens. But because it is only bonded to one other carbon, so we are going to say it is a primary allyl. This carbon here, it is in a double bond. So it is what? An allyl also. But because it is bonded to how many carbons? A carbon here, a carbon here, a carbon here. So it is a tertiary allyl carbon. This carbon is a carbon bonded to a carbon in a double bond. So it is a vinyl carbon. It's actually a primary vinyl because only bonded to one more carbon. This carbon here is also vinyl because it's bonded to a carbon in a double bond. But it is a secondary vinyl because it's bonded to two carbons. It's bonded to this carbon, this carbon. The rest of the carbons will not classify them as being allyl or vinyl. This carbon here, it's bonded to three other carbons. So we just say it is a tertiary carbon. This carbon at the end here, it's only bonded to one carbon, that is a primary carbon. This carbon here is also a primary carbon. Carbon bonded to only one carbon is a primary carbon. Two carbons is a secondary. Three carbons, tertiary. And then in a double bond, allyl. Bonded to a carbon in a double bond, vinyl. That is how you classify them. Now, alkenes exhibit what we refer to as cis and trans isomerism. When you have got the same group on the same side of a double bond, we call that as a cis. So you can see this one has got only two carbons, 1 and 2. So when you are naming this, you say name first the substituents. So position number 1, you have got a chlorine, 2 also a chlorine. So that is 1, 2 dichloro. This is an ethene. It's not even necessary to say one ethene because there's no any other point where the double bond is going to be. But because the chlorines are on the same side, you say cis. If they are on opposite sides, you say trans. And normally the cis is much unstable because of repulsion. These two guys are going to be repelling each other. So the most stable form of an alkene is the trans. How about if you have got a double bond and a triple bond in the same compound? Triple bonds, you name them as alkenes. So an alkene with two carbons is called ethene. Remember, F is for two carbons. How about this one? How many carbons does this have? If you can't count the carbons, you can't answer this. So at every end there's a carbon. C is 1, C is a 2, C is a 3, C is a 4, 5. 5 carbons with a triple bond at position number 2. So that is 2 pention or pentyl or penti 2 ion. How about if you have got in the same molecule double bond and a triple bond? When you are numbering, priority should go to the double bond. So this will be your first carbon, second carbon, third carbon, fourth, fifth. but the parent chain is always the triple bond. So when you're naming this compound, it has got 5 carbons. So we're going to say pent, state first the position of the double bond at position number 1, N. But remember, this is not an alkene, right? Drop the E at the end and then put a position of the triple bond 4 and then ion. Now, this is in a case where they are competing, the double bond and the triple bond is competing. Always number the double bond first. But in a case where they are not competing, the one which comes first to receive a smaller number. For example, let's say we had something like this. Here, the double bond and the triple bond are not competing. So always start, because the triple bond is coming first, number starting from where it is. So this becomes hept. Now you always name first the double bond, because the triple bond will always be the parent name. So hept 4N. Drop the E at the end of N, and then now put a position of the triple bond 1 ion. That is how you name them. If you have got an alcohol in it like this one, the alcohol wins priority over a triple bond. So count in the direction, that will give a small number to the alcohol. So that becomes this one has got 5 carbons with a methyl as a group. First name the methyl as a group, so that is 2-methyl, 5 carbons, so that is pent. Put a position of the triple bond 4 ion. Drop the E at the end of ion because it's not a parent name, and then put the position of the alcohol 2, and then put O because alcohols end in O. Double bonds can also exhibit the EZ configuration. Only double bond, nothing else, only double bonds. Now, EZ configuration, what you do is that you are going to look at where the double bond is. Where the double bond is, and then try to cut it on the middle. Try to cut the double bond on the middle. And then you are going to see two groups on one end, and then also two groups. You can only determine EZ configuration if the molecule that you are talking about has got different things. If this was a hydrogen and then this group was also a hydrogen, you can't determine EZ configuration. You can only determine cis and trans. So, how do you determine EZ configuration? If you break your double bond on the middle like this, you look at these two groups which are on the same side. Which one has a higher molar mass? The one with a higher molar mass, label it as 1. Come also this side. Which one has a higher molar mass? The one with a higher molar mass, label it as 1. If the two guys with a higher molar mass are on opposite side, you can see this one is on top, this one is down. That is the E configuration. If they are on the same side, that is the Z configuration. The Z configuration is the same as cis. And then the E configuration is trans. So there are some practice questions here that you can be able to work out to determine the E and Z configuration. Now in these molecules, we also have the RS configuration. So that is another thing that you should be able to understand, RS configuration. When you're determining RS configuration, you just look at a molecule. Now normally when you write a molecule, you are going to have atoms which are coming towards you, atoms which are going away from you. For atoms that are coming towards you, you use a wedge. So if you see this, it means that that atom is coming towards you. Like the way I'm looking on the board. Let's say this is a hydrogen, right? I'm looking in the board. This is a hydrogen. It means that this hydrogen is pointed to me, pointed to me. And then if you see lines like this, it means that something is going away from me, like it is entering the board. And then if you see things on just lines, it means that they are parallel to the board. Say they asked us to name this molecule. Now the first thing that you do is you are going to make sure that you look at the molar mass of the atoms bonded to the chiral carbon. We can only determine RS configuration if this carbon is bonded to four different things. If any one of them are the same, you can't determine RS. Only for four different things. So since all these are different, now which ones have got the highest molar mass? Chlorine here is going to have the highest molar mass, so it will be the first group. Now RS configuration is different from EZ configuration. When you're determining RS configuration, you don't look at molar mass of the entire group. Like you look at the molar mass of the entire group. No. You look at the molar mass of the atom directly bonded to the chiral carbon. So you are comparing carbon. Here the atom bonded also direct to that carbon is a carbon, a hydrogen, and a chlorine. Which has a higher molar mass? Chlorine has the highest molar mass. So this will receive position number 1. And then go now to the next atoms. So a carbon and a carbon, I can't determine which one has a higher molar mass. Go to the next atoms they're bonded to. This carbon next is bonded to a hydrogen. But this carbon next is bonded to a carbon. And the carbon has got a higher molar mass than a hydrogen. So this group here is going to end up winning. And then this one will end up also winning over hydrogen because this one has a higher molar mass than hydrogen. So hydrogen will be the last group. After you do that, now you need to make sure that the fourth group is at the back. When you write wedge, it means that something is in front. Dashes mean that something is at the back. The fourth group should always be at the back. But because this one is not at the back, so what you do is the fourth group is not even necessary to number it. Just number the first three. The fourth group, just leave it out. You are going to connect numbers from 1 to 2 to 3. 1 to 2 to 3. If you see a line going in this direction, that is S. If you see a line going in this direction to the right, that is R. So meaning that this configuration new is supposed to be S configuration. But because the fourth group is not at the back, you change configuration. The fourth group is not at the back, so this name changes. Instead of it being S, it becomes R. So to name this molecule is going to have a configuration of R. But that's not the name, that's just a configuration. So what will be now the name? Remember to count the longest continuous carbon chain. So be carbon number 1, carbon number 2, number 3, number 4. Position number 2, I've got a chlorine. So this is going to be R2 chloro. So one has got 4 carbons, butane. So this is R2 chlorobutane. That is how you determine the configuration. Let me just answer one example on these questions, because some of them they've got a mixture of R configurations and EZ configurations. Let me answer this one down. First thing is count the longest continuous carbon chain. So when counting, you start from here. So be position number 1 carbon, number 2, number 3, number 4, number 5, number 6. Meaning the name of this compound is going to be already, before you even name it. Position number 1, we have got a bromine as a group, a chlorine as a group, a methyl as a group. So we need to name those groups. B comes first before C, and C comes before methyl. So we're going to say 1 bromo, and then 2 chloro, and then 3 methyl. Now this chain you can see has got a double bond that has got 6 carbons. So we're going to say X. At position number 1 there is a double bond X1N. I've named it, but I've not included configuration. So I need to include now the configuration. The first configuration I'm going to talk about is the E and Z. Where I say double bond, let me determine the E and Z. So look at this group and this group. E and Z, you look at the molar mass of the entire group. So this one which is down is going to win. And then this and this, the bromine is going to win. You can see these two guys are on opposite sides. So that is going to be, is it E or Z? What will be the answer? Is that going to be E or Z? It's E. Okay. But remember this double bond is at which position? It is position number 1. So this is actually 1E. And then at this point you can see there is stereochemistry there, meaning that you have got RS configuration. Every time you see a dash and a way, just know that is going to be there. So determine the first group. You have got a methyl, a hydrogen, this group, and this group. Which one is going to receive the highest priority? Already you can see at least this group on top has got a chlorine, so this group will receive the first priority. Which one will be the next? Why? Because it has got a higher molar mass. And like you look at the atoms that it attached. This one is attached to a carbon, attached to a carbon, attached to a carbon. So we can't determine. Go to the next atoms they're attached to. Attached to a chlorine, only to a hydrogen. This one is attached to a carbon. So chlorine wins. And then this one attached to a carbon will become the second. This one attached to a hydrogen becomes the third. The one attached to a hydrogen, the hydrogen will be the last. So now count from 1 to 2 to 3. So this configuration is supposed to be R. But look, the fourth group is not at the back. Since the fourth group is not at the back, change configuration. So that becomes S. Okay. But at what point is that? At what carbon is this configuration? 1, 2, 3. It is a position number 3. So it becomes 1E, 3S, 1 bromo, 2 chloro, 3 methyl, like that. And then the last concept in this class we need to understand is the degree of hydrogen, the degree of unsaturation, also called the index of hydrogen deficiency, IHD. IHD is given by 2C plus 2 minus H plus N minus X over 2. The meaning of this is that you just get 2, you multiply with the number of carbon atoms, you always add a 2. Hydrogen always subtracts from IHD. X is representing halogens. Halogens, you always subtract IHD. Alright, always subtract IHD. Nitrogen is representing like group 5 atoms. Group 5 atoms always add IHD. Group 6, they don't affect IHD. That's why I can't see oxygen here. If you have got a compound that has got oxygen, IHD will not be affected. If you find that your IHD is 1, it means that you have got one double bond or you have got one ring. IHD of 2 means that you have got two double bonds in the same molecule, or you have got two rings, or you have got one triple bond. Two IHDs is one triple bond. Or it means that you have got one double bond and one ring. How about an IHD of 3? IHD of 3 will mean that you have got either 3 double bonds or you have got 3 rings in the same molecule, or you have got, let's say, uh, 2 double bonds and one ring. Remember, one double bond is one IHD, or it means that you have got 2 rings and one double bond. Remember, a double bond is one IHD and a ring is one IHD, or it means that you have got one triple bond and either one ring or one double bond, because one triple bond means two IHDs. So from the 3 remove 2, you are going to remain with one IHD. That other one IHD, it can either be a ring or a double bond. 0 IHD means that you don't have a ring, you don't have a double bond. So these are some practice questions from last year's tutorial sheets that you should answer. Let me just answer for you one question. Let me pick this one. Calculate the degree of unsaturation and suggest two or three possible structures. Name the functional groups. So for this one, remember IHD is equal to 2 times the number of carbons. There are 10. You always add the 2. Remove the hydrogens that you have got 11 hydrogens. Nitrogen adds to IHD. And then over 2. So this is going to give us 2 times 10 is a 20. 20 plus 2, what is that? Is a 22. And then negative 10 plus 1 is a negative 11 plus 1 is negative 10. Right? Oh, there's something that, okay, let me first go on. 22 minus 10, what is that number? Is it a 12? 12 over 2. So there's something that I've not even included there. 2 times C plus 2 minus H plus nitrogen minus halogens. Why didn't I include 2 carbons, 2 hydrogens? Okay, 2 times 10, we have said that is a 20, plus 2 is a 22, minus 10 is a 12 over 2, that is a 6. This number is too big. Oh, no wonder. So this is 14 plus 2, which is a 16, right? 14 plus 2, which is a 16. And then minus 10, that is a 6, divided by 2, that is a 3. So an IHD of 3, there are different meanings. It means that we have 3 double bonds, or we have got 3 rings, or we have got 2 double bonds and 1 ring, 2 double bonds and 1 ring. Another meaning is that we have got 1 triple bond with a ring or a double bond. So those are the different meanings. You can see there are a lot of different meanings. So looking at the formula, 7 carbons, we want to suggest any 2 or 3 possible structures and name their functional group. 7 carbons, 1, 2, 3, 4, 5, 6, 7. But remember, it has got a nitrogen. What functional groups can nitrogen make? One functional group a nitrogen can make is a nitrile. A triple bond with carbon, that's a nitrile. And if I use a triple bond, it means I've covered 2 IHDs. And it means I'm remaining with 1 IHD, and that other 1 IHD, we said that it can be a double bond. Or if I use a triple bond between a carbon and a nitrogen, this is 1 carbon, there are 7. It means that the other carbons, I can also put them in a ring because already this is 1 IHD. So this is carbon 1, carbon 2, let's say carbon 3, carbon 4, carbon 5, carbon 6, and then I can say carbon 7, and then I join like this. It doesn't matter any ring that I form. 1, 2, 3, 4, 5, 6, 7 this carbon. If you count the number of hydrogens, they are going to also prove to be 11. So I can write these 2 structures with a nitrile functional group. Another functional group that can come from a nitrogen is an amine functional group. So I can write 7 carbons, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But a nitrogen bonded to 2 hydrogens, that is known as a nitrile, an amine functional group. Not amide, amine. But there is no double bond here, meaning that I've not catered for any IHD. So for me to cater for the 3 IHDs, I can either use three triple bond, double bonds, or I can put one as a triple bond, the other one as just one double bond. That is the three IHDs. That is how you do it. So there are a lot of possible structures that I can write here. A lot. And then you can also try out this question. Provide an explanation for the following observations. The boiling point of cis-2-butene is higher than that of trans-2-butene. Why? Trans-2-butene is more stable than cis-2-butene. Why? Remember we talked about the trans being stable than the cis. Why? I already mentioned the reason there. And then rank the following in order of the priority, beginning with the lowest priority. When you are ranking in order, the same way we determine E and Z, just look at the molar mass of the compounds. It will give you the one which is as higher priority. Write the 2D or 3D stereochemical formulas and give the name as either E or Z designation for the isomers below. Let me just use write for you one. 2 bromo 4 cyclo-X 2 N 5 ion. So from the end, the name at the end, ion, and this is, remember, Xz, meaning that is 6 carbons, right? 1, 2, 3, 4, 5, 6. But from the name 2 bromide, position number 2, I've got a bromine. And then 4 cyclo, at position number 4, I've got a, 4 chloro, position number 4, I've got a chlorine. X is 2N. Now 2N means that at position number 2, I've got a double bond. And then 5 ion. This is 1, 2, 3, 4, 5, 6. Position number 5 ion, meaning that we have got a triple bond here. Okay. And then also designate whether it is E or Z. Now you can see this molecule, if I cut it on the middle like so, even if you can't see there's an hydrogen here, you can see this group will receive priority, this will be 1. And then for this other side of the equation, we have got a bromine and a methyl. This one will receive priority, so it will be 1. Because the two groups of priority are on the same side, this is going to be Z. On the triple bond, you can't mention whether it is E or Z. EZ only applies to double bonds. Also, this one, write the name of the 2D structures, include the pertinent stereochemistry. So you need to state whether it is E or Z. Let me just answer one. Let me answer this one, the last one. First thing that you need to do is you need to know where you're going to count from. If I start counting from here, 1, 2, 3, 4, 5, 6. You can see the first group is at position number 3. Should I start counting from there? No. Because if I start counting from the other side, the first group will receive a smaller number. So you see 6 carbons, so we're going to say X. Now when something has got 2 double bonds, you are going to put an A. Instead of saying XZ, put an A there, it becomes hexa. And then put now the position of the double bonds at position number 2 and at position number 4. Hexa 2, 4, and then put di N because the double bonds are the two of them. Now let's determine whether it is E or Z. At position number 2, if you cut a molecule like this one is going to have higher priority than this one. So this is going to be a 1. But this side, because these two guys, you can see they are the same. We can't determine stereochemistry if we can't determine E and Z. If, remember what you said, if they have got the same group, should be 4 different things. And then at position number 4, let's come and break the bond here. Of course, there's a hydrogen here. Between a hydrogen and a methyl, methyl will receive 1. Between a methyl and this big group down here, this big group will receive a 1. You can see they are on the same side, those with highest priority. So at position, what carbon is this? This is 1, 2, 3, 4. So at position number 4, we have got Z configuration. So it becomes 4Z hexa 2, 4 di N. If they say here it was also giving us E, we could have said 2E, comma, 4Z, and then we say exa 2 comma 4 diene. But because these groups are the same, we can't determine any configuration there. Also, you should try out this, and this question I'm going to send you. See, this was in last year's test 1. Determine whether it is E or Z. Let me determine for you this one. So all you want to do is determine whether which group is going to have priority when you cut a double bond. So if you cut a double bond here, between the group on top and the group down, which one is going to have highest priority? So the group down is going to have highest priority because that's a higher molar mass. Carbon, oxygen, nitrogen, these have got a high molar mass than what is on top. So this will be 1. How about this one on top? Now you can see, how do you determine which one is going to have priority? So look, if you go in this direction, you are finding a methyl. If you go in this direction, you're not finding any methyl, meaning that going up this direction, this one is going to have a higher molar mass. So these two groups of higher molar mass are on opposite sides. This is E configuration, and this question was just asking us to design whether it is Z or E. We can also try out this, determine whether it is R or S. Okay. Mhm. No, no, if there was no methyl, then there don't be any EZ configuration here.